Hi, this is James Ramsey, Group Product Manager here at GitLab, and I'm looking into improving the way we allow you to back up your Git repository data on GitLab. So I've got some ideas from reading a couple of issues and feedback from customers, but I thought the best place to start exploring was to actually try and do a backup. So I've created a GitLab instance here and imported I don't know, 8 or so large popular repositories, and I'm going to try and back them up. So I've gone to the documentation, and I want to use cloud storage, object storage to store the backups. So I've gone and configured Google Storage. At least I think I have. I did that before the recording, so you didn't see my tokens. But this is the bucket I'm aiming to put the data in. As you can see, there's nothing in here. So let's go to the docs and see what it has to say. Okay, backup. Use this. No, I haven't done it from source. All right, let's just do a simple backup. All right, this node was configured with a Gitaly cluster, so it's 3 prefect and 3 Gitaly nodes. So those large repositories should actually be living on these 3 nodes. I think it's about, looks like maybe we've got 8 or so gigabytes of repos. Okay. So here we can see it doing some dumping, wikis. Let's double check that all the repos are ending up on the prefect cluster repository. Yeah, everything's going to storage 1, which is one I configured the other day to use these nodes. I think that one is the primary. I'll just go here to check my dashboard. Prefect. Oh, it's Gitaly 3. Okay, so that's helpful. Tail Gitaly. So should see some output. Okay, so we're still just working on these wiki repos. And these wiki repos, I presume, are quite small. Oh no, they're skipped. Skipped wiki, oh, probably because they're empty. Okay, so these are the actual backups of the really large repositories. So it looks like these repositories are being backed up sequentially, which is interesting because there's probably enough capacity on these servers to be running the backup more than sequentially. Exactly how much parallelization we should be enabling is hard to know. Looking at the dashboard for Gitaly, I'm not actually getting any useful information. I'm only seeing the Gitaly, one of the Gitaly nodes, which is running locally on the Omnibus server, and not actually the Gitaly nodes that have the data on them. So maybe that's a misconfiguration issue on my part. But we're getting through them. So we'll see how long this takes. While that's happening, I'm going to flip over the docs, move into this side of the page so we can see everything that's happening at the same time. Multitask. What options do we have? Backup strategy option. Streaming strategy. Stream data to the backup using tar gzip. Okay. Okay, and the copy process. requires up to 1x disk space. I wonder how much disk utilization we're using on this primary. Oh, that's the wrong server. Let me print the IP for that one. Should have got it handy here. D/F. And it's just df-h. Okay. So we've got enough disk space. Okay, now tower balling it up. Gosh, that is not ideal if we had more data than this. Like, we're only compressing a couple of gigabytes of data, but this could quickly get very slow. So let's see if we could, how we would go about setting up some other ways. So we've also got this backup dump. Okay, that's for like overwriting the file name. Rsync. Can I check? I guess I can skip everything except your repository, so we can focus just in on that. Okay, so now we're doing the upload. Right, the command started at 3:33, so we're taking like 6 or 7 minutes so far. Done. Deleting our backups. Okay. All right. Okay, so the whole backup is only 3.5 gigabytes. Not too bad, not too bad. I wonder what would happen if we imported like a really big repo in parallel. Let me, what's the WebKit repo? It's a big boy. Let me just stop sharing. Otherwise you're gonna see my access token. I'm just running an API command to trigger the import because I have it handy. Okay. Start sharing my screen again. Okay, so I just triggered the import back there. If we go to my projects, we'll see WebKit's now being imported. That should be quite a lot larger and slow things down. But in the meantime, let's take a look at these options and see what we can exclude from the backup so we can just focus on repositories, because that's really what I'm interested in. So skip DB uploads. No. Skip DB uploads, builds, artifacts, builds, artifacts, LFS, registry, pages. The other thing I want to do is see what happens if we skip the tar creation, how that's going to work. especially in combination with the object storage upload. So let's see what happens. I wonder if they should have all been provided as one comma separated list. Probably. Maybe Rails is smart enough to handle this. All right, there's a fair lot of thinking happening. Interesting, dumping database. I thought I skipped that. I did skip the database. Maybe it's just skipping the tar command. Let me try this again. I'm gonna bail out on that. Try this. Okay, that's more promising. Deadline exceeded. No deadline, no deadline time. Has local branches. Let's keep looking, perusing the documentation, see what we find. Okay, so I already configured this one. Figuring con. So I guess what we're trying to work out here is how we might make these backups faster. And once a repository becomes of a certain size, if you've got thousands of repositories, even if they only take a minute each or even 30 seconds each, your backup quickly takes hours and hours and hours. And it's not unforeseeable that you would have a lot of large projects, be they forks of open source projects or huge internal projects that you've developed over many years. The backup could take a long time. Because it's not uncommon for an instance with thousands of users to have hundreds of gigabytes of repository data. So that could take a while, particularly that we're doing these in serial. There's a bunch of workarounds that some people follow, which are to take disk snapshots or other kinds of snapshotting approaches that look at the raw repository data on the disk. The problem with those approaches is that the repository might not be snapshotted in a consistent state. If you've got writes happening and it's sort of taken in a rolling fashion through the repo, you can't guarantee that you snapshotted the refs and then you snapshotted the objects. And so that you might actually have commits or objects or refs that reference things that don't exist. And that would be a problem if you're trying to restore from backup, because then you'll find that your Git repository is corrupted and it's going to need manual repair, which is going to be quite stressful when you're trying to recover from a backup. Generally, there's enough stress involved in a backup without added data corruption concerns. So we want to make sure that the backups are consistent. We also want to make sure that they're fast. And the other issue is that depending, and this is why I'm a little disappointed that I couldn't work out how to make Grafana work for the wrong Gitaly node, is the resource utilization could be really high. So making sure that we're able to take backups quickly, that they're consistent, and they don't put too much of a load on the server is a real consideration that we're trying to look at. I wonder how the application's performing if I just go to one of my other projects this Gitaly one, it's not too bad. I mean, these are pretty big boxes though, so I would have kind of expected clicking around. Well, it's not too bad. But I can imagine if you've got a large read load already with CI servers, lots of users doing Git operations, the added load of doing all these Git bundles would really add up. Let's see what the disk space is coming in. Still only reporting 8.4 gigabytes used, which seems... So this one's the secondary, so it won't have the disk utilization updated until this is complete. So let's take a look at this one. df-h. Yeah, okay, so utilization's up to 17 gigabytes. So WebKit's something like 20 gigabytes from memory. CD. I can't remember where these are stored. Where are repositories stored on disk? I can look, I think this actually maybe. Okay, so I'm guessing that is going to be the big one. Backup's still going. It's not even trying to back up WebKit yet. WebKit's not even finished importing yet. Aborted. No such file or directory. So object storage uploads don't work unless there's a tar. That's interesting. Did the documentation say that? Okay, I guess it's implied by the fact that it uploads the tar. So if we skip tar, it can't upload. That's interesting. So I wonder what directory it creates the backups in. It's probably not. Okay, the backup path. What is the backup path? I'm just going to pause the screen share. Backup path. Opt git backup. I'll zoom my share. Sorry, I've just got secrets in here. Backup path, so there we are. So we'll jump on out of that. Head over here. Okay, these are the ones we just took. Repositories. So if we see what we found. 53, something here. No, there's not. Okay, there is something here. Let's go to 5. Okay, there's the bundle. So it's just a git bundle output. So I guess one of the ideas would be that if we could keep track of these backups, rather than treating them as like specific time-stamped repository backups, but instead calculating the checksum of the bundle. So when we generate, let me rewind. So with Git repositories, we have a method, an internal method for calculating a checksum for the repo. So we can run that and work out if two servers have the exact same state of that. So if we stored that checksum with the bundle somehow, then we could compare the backup we last took with the current checks of the repo. And so if I'm taking another backup and I just took one 12 hours ago and the checksum hasn't changed, then maybe I don't need to back that repo up again. So depending on the level of churn, it could cut the number of backup jobs to a fraction of a percentage. Maybe it's 5% or 1%. It's likely to be a significant savings. And then even further than that, we could iterate on taking even smaller snapshots. Rather than taking a full snapshot every time the repo changes, we could look at taking an incremental backup. So those are some areas that we're exploring, and we'll need to work out how this plays into not only the backup process, but also how we restore and how the data would be structured in an object storage environment where we'd presumably typically store these kind of backups. But then again, these could just also be on any file path. So those are some ideas that we're evaluating. But yeah, it looks like things are quite basic, quite slow, even for a instance with only a handful of large repositories. This thing was really slow. All those repositories were less than a gigabyte, and it's really not that uncommon for large organizations with historic projects that have been going for 10 plus years to have much larger projects than this, which would take longer to back up. So important that we solve these problems. This was insightful for me. Feel free to jump in on the Epic, ask any questions, give your feedback. Here's the Epic 2094 incremental repository backups. So looking forward to your feedback.